All right, guys, welcome back. We are continuing our radical discussion. We were talking yesterday about radicals and how you read them. Remember that we're talking about this is the index over here, and what's inside is the radicand. This number here is the index that tells you the root, and the actual symbol itself is called a radical symbol. Okay? Please remember that when we're talking about the root, all right, that tells you the number of values in each set that you need to pull one of those values out. And we started with the simple example of square root of 25. Square root of 25, there's an invisible 2 here as the index. So that means I'm looking for sets of 2. So 5 times 5 is 25. I have a 5 and a 5. It pulls out as a 5. Have nothing left over, and I'm done. Okay? That's the concept behind what we're doing today. We're looking for sets of values, and we're pulling out one of those values for every set that we have. Okay, I think we talked about all of these yesterday. We said that the cube root of 0.008, that's basically what number times itself 3 times gives me 0.008, and I believe that we all knew that it was 0.2. We knew that the cube root of negative 1,000 is negative 10, because negative 10 times negative 10 is a positive 100, times a negative 10 is a negative 1,000. And then 1/27ths, we're going to have 1/3. Now, what happens here, guys, is when you have a radical and you have a fraction under the radical really belongs to both the numerator and the denominator. So sometimes it benefits you to break it up. This is the cube root of 1 over the cube root of 27. The cube root of 1 is 1. The cube root of 27 is 3. So in this case, it's nice and easy. Does that make sense? Okay, awesome. So now we're talking about what are the fourth roots of the following numbers. What's the fourth root of 1? 1. Very good. What is the fourth root of negative 0.0001? No solution. Okay, remember, guys, you cannot have a radicand that is negative in an even root. Very good. Yes, sir. Okay, we're talking about real solutions. If we wanted to find the fourth root of this, then yes, it would be 0.1i. I is the square root of negative 1, but we're not there yet. So if you put I here, I'd have to mark it wrong because we're not there yet, okay? So no, and also with all due respect, what are the real fourth roots? So there are no real fourth roots because negative 0.1 times negative 0.1, yes, that's positive 0.01. Very good. Then times a negative 0.1, it's going to be negative 0.001. And then times another negative 0.1 would be positive 0.0001. You can never multiply anything together of the same number to give you a negative. Negative 2 times negative 2 is positive 4. Nothing times itself will ever equal a negative. It never will, guys. Negative 1 times negative 1, positive 1. Negative 2 times negative 3, positive 9. Okay? You can never have a negative radicand in an even root. Great job. Now, what's the fourth root of this bad boy? That's exactly right. You guys are going to do very well at this. You guys are going to do very well at this. Beautiful. Now, that was the Mickey Mouse stuff just to kind of get your brains in gear. Now let's do the real stuff. And this is still Mickey Mouse. This whole chapter is Mickey Mouse. You're going to love this. The cube root of 8. You guys are very quick, okay? You guys are good with your numbers. So I'm not doing this because I expect you to do this for the little Mickey Mouse ones, but I'm going to show you the procedures that I use when you get into monster numbers. So that way you know the procedure. We all know the answer to this is 2. Yes, I know. I'm not thinking that you don't know that. But why is it 2? Because 2 times 2 times 2 is 8, right? Or let's just say that it was someone who didn't know their times tables very well. They'd go 4 times 2, that's done, and then 4 breaks up into 2 times 2. I have 1, 2, 3 2s. I'm looking for sets of 3. That's why it's 2. Okay, I know that makes sense, but did you understand how I broke it down? If we were talking about crazier numbers, this is how we would break it down, gentlemen. Okay? In my opinion. Now here, okay, it's going to be 0.2 times 0.2. It's a square root. I'm looking for sets of 2. So I have 1.2, 2.2s. So that comes out as 1.2. Okay? What's the fourth root of negative 1? Not possible. No solution. Actually, there is a solution, but it's not real. This is a real, we're looking for real roots. Okay, this is a very good one. D, what's the square root of parentheses negative 2 squared? No. It's going to be 2, guys. And I'll show you why. Look, what's negative 2 squared? So square root of 4 is 2. If I said plus or minus, if I wanted both roots, it could be plus or minus 2 as well, either way. Right? Because negative 2 times negative 2 is 4. Right? Right, guys? And 2 times 2 is 4. So in this case, you had to do the parentheses first. What's the cube root of negative 27? Negative 3. Now, let's say a lot of people don't know this. So they're going to go, okay, it's negative 3 times 9, and then 3 times 3. Okay? But, so you have a negative 3 come out. You with me? Yes, sir.
So, like when you factor it out,
that'd be negative and negative. Yeah, because you know that when you have a cube root, if it's negative, the answer will always be negative, is what my boy was asking. Always. If you have a negative in a cube root, I promise you, your answer is going to be negative. I promise you. Always. Does that help? Thank you, sir. Here, what's the fourth root of negative 8? No solution. Cannot have a negative radicand for an even root. We're good so far, my brothers? Okay, now let's get to the good stuff. Hi. What is this saying? This little fancy stuff over here. It says that when you have the nth root to a to the n, okay, it's going to come out as just a regular a if n is odd, and it's going to come out as an absolute value if n is even. Okay, now, some of you are like, what the heck does this mean? And wait a second. I shouldn't have 2 n's. I shouldn't have 2 n's. I should have an m there, as in Mary. Or actually, no. I should have the n here and the m here. Sorry. I'll fix it manually right now. This guy here should be an mth root. Okay? So basically what's happening is here. In other words, when you take out an odd exponent from an even root, it must be an absolute value. When I take out an odd exponent from an even root, it must be an absolute value. What on earth am I talking about? Let's say I tell you the square root of x to the 6th. Okay. Square root means that there's an invisible index of a 2, right? So I'm looking for sets of 2, correct? When I'm looking at variables, the best way to do this is to divide. How many times? What's 6 divided by 2? So I'm pulling out an odd root, correct? Since I pull an odd exponent from an even root, I better put in an absolute value. That's the only restriction. If I'm taking something out of an odd root, we don't care. Why do you think it would be important to take it out as an absolute value? Thank you, sir. Since it's an odd root, it could be negative. And I cannot have negative values inside of an even root. So again, When I take out an odd exponent, like this x cubed here, from an even root, I have to put in an absolute value. And we're going to do a bunch of tests now. We're going to do a bunch of practice. But does that make sense, guys? Okay, now, let's check it out. What's the square root of 16x to the 8? 4x to the 4th. Remember, not an absolute value. First of all, is this an odd exponent? You only make an absolute value if you take an odd exponent out of an even root. You got a question, my man? Okay. Why did I get 4? What's 8 divided by 2? 4. Boom. Let me just, for giggles, just so you know. Let's say I said x to the 9th. This would be 4 x to the 4th, but won't I have 1x left over? That guy stays inside. See what I'm saying, guys? Let's go a little bit further. Let's say I told you square root of 32, and let's say x to the 11th. Okay, 32, this is 16 times 2. So I know that 16 is a perfect square, so I got 4. 11 divided by 2, that comes out 5 x's. But what's left over that I couldn't pull out? 2 and 1x. So all leftovers stay inside the radicals. Does that make sense, guys? That helps a little bit. Okay, good. Now let's see. I'm hearing a lot of good noises, I think. Yes, sir, my brother.
If you take out an even number.
If you take an even from an odd, it doesn't matter.
Yeah, no, but if there's an even number and you take out an odd and you take out an even.
Okay, only the odd has to be in square root. Okay? Whenever I take an odd from an even root, only that odd has to be in an absolute value. How about b, guys? The cube root of a to the 6th, b to the 9th. Just divide. So this is going to equal a squared b cubed. You do not, I repeat, you do not have to worry about absolute values with odd roots. The only time you got to worry about absolute values is with even roots, and that's if and only if I take an odd exponent out of that even root. How about here? What's the 4th root of x squared? 4th root of x to the 8th, y to the 12th. X squared, absolute value of y cubed. Right, guys? Because I took out an odd root, an odd exponent from an even root of 4. Do you guys see that? That's where a lot of people get messed up. But we're going to fix that today. Okay. The question was, how do I know it's odd? Because numbers like 1, 3, 5, 7, 9, 11, those are odd numbers. So 8 divided by 4 is x squared. 12 divided by 4 is y to the 3rd, which is an odd number. So I put that in absolute value. Anytime I take out an odd exponent from an even root, I have to put it in absolute value. All right, now, how about D? A to the 4th, B to the 5th. Done. Just for giggles, what have I had? A to the 17th, B to the 19th. Okay, A to the 5th, and B to the 6th, but then I have a cube root of what? A squared and a B, because that's what's left over. You guys seeing this? Yes, sir, my brother. What? Okay, sir. 17 goes into 3 5 times. Right? Because that's 15. And I have 2 A's left over.
No, I get that.
Okay.
Before, like when you said that we have to put extra stuff in the radical, like it stays in it, you put 2x. You put an x.
Oh no, because that was a variable.
Yeah, it wasn't a variable when I put that 2x in there. It was the number 2 that was left over. He's talking about this. Okay. He's confusing me because he didn't write it down. If I have this, 32, for example, x to the 9th, and I have the square root of that, This is 16 times 2. So this is 4x to the 4th. And what do I have left over? 2 and 1x. Are you with me, sir? Thank you, sir, for your honesty. Sir,
The 3 in the index.
you have to keep this 3 in the index for sure, because we're talking about a cube root. That's a great question. A lot of times people forget that and they'll just put the square root symbol and then it's wrong, because it's still a cube root. Thank you very much. Good questions, sir. Good questions, guys, in general. What's the square root of 81x to the 4th? 9x squared. Done. What's the 4th root of x to the 12th y to the 16th?
X to the third. Absolute value. X to the third.
Absolute value x to the 3rd. Y to the 4th. Heck yeah. Does that make sense, gentlemen? Alrighty. I think we are done. Yes. We're good? Sir. Shh, guys, hold on. Sir. Are you sure, my man? That's what I'm here for, dude. Ask away, dude. I don't care. You sure? Alright. Let me just give you one. I'm going to try to give you the most complicated one that they can possibly give you right now at this stage of the game, and then we're going to move on to the next section, okay? So, at this stage of the game, when we're just, simplifying radical expressions, all right, how about this, guys? What would it be if I gave you, at this stage of the game, what if I gave you this? What would that be, boys? The 5th root of 32y to the 15th. Okay, I'm glad we did this. Let's break this down. Isn't this 2 times, hold on, guys. Ain't that 2 times 16?
Yeah.
Then isn't this 2 times 8?
Yeah.
Then 2 times 4? Then 2 times 2, right? See, I told you it's not always going to be just, boom, magic. I have 1, 2, 3, 4, 5 2's. So that's going to equal 2y to the 3rd. No, it's not an absolute value because I have an odd root, an odd index. Does that make sense, guys? And you see how I broke it down? I knew that the 5th root was 32. I knew it was 2. Whoop-de-doo, good for me. If you don't know that, that's okay. You break it down. Does that make sense, gentlemen? Promise? Okay. I'm going to stop this recording now, and then we're going to start a new one, all right?